Well, hello and good morning, everybody. I hope you are ready for another webinar. Okay, we got everything handled here. Nothing's going wrong, we promise. Had a dog barking for a second. Anyway, yes, we have another webinar. If you are new to the little Zoom meetings that we've been using, go to the top. I sure like going to the view options up there and exiting full screen myself, just so it doesn't totally take over my monitor. So that's definitely a nice little tip. And of course, you have that Q&A box. Do please get your questions in. We are going to be going over a lot of really interesting topics today, specifically about troubleshooting these problem irrigation plans. A lot of things that have come up over the last number of weeks, frankly, and Jake and I have been kind of consolidating some good test cases to go over. So as fun things come up, do please get your questions in. We should definitely be able to address some things. I think that is good enough from my perspective. I'm going to get this handed over to Jake.
Great. Thank you, Jeremiah. Welcome everybody to this advanced irrigation troubleshooting webinar. I'm so excited to do this. Only from the perspective of, irrigation's one thing, troubleshooting is a different thing. I am an avid puzzle guy, and combining the two things does make for an interesting little topic here. So hopefully, as we go through some stuff, that we're going to be showing broken stuff. Hopefully it ends up being broken, that we can actually show fixing things and breaking things again. We'll see if it works out here. So the quick little outline that we got going on here for our agenda today is we do want to touch on equipment data, the symbols issues stuff that we got going on. If you have not watched our previous irrigation sort of tools, what you need to know webinar that I did, we did go over a few of these items. We are going to touch bases briefly on a couple of those issues again, but really looking at a few other messages that you might be getting and how to actually correct those items. How to review a valve analysis. We're going to just take this sort of as a particular instance. This could apply to other schedules and stuff as we get down through the list, but really understanding that pressure loss and the precip rates and stuff that you are seeing as you are sizing your main lines and stuff like that, you start getting those messages that you've exceeded the pressure, that kind of thing. So we want to make sure that we kind of understand how that's working and just looking at equipment in general. So we'll look into a little bit of the sizing techniques, maybe using spot elevations, looking at caps, looking at flow zones, and how those actually play into sizing of those main lines. And then obviously utilizing those schedules, the valve schedule, critical analysis, to really check and make sure that your precip rates and the data that you've actually put into the design is what it is, and how to maybe use a couple other little hidden tools that you may not know about. Locate valves is a great one if you're not aware of that one, so I'll try to show that one as well. So aside from that, really the verification tools, and this might be, we call this the advanced troubleshooting webinar, but when it comes down to it, using the most basic verification tools that we offer, just how to use those, where to look, and even bringing into play a couple other little tools, and hopefully they'll prove beneficial to you. So and then I would say sporadically through, feel free to enter your questions in there so we can get them answered. Maybe we can try to create some issues on the fly and how to resolve those. So as we get into it a little bit more, we do want to almost give you somewhat of a standard troubleshooting process. Now, this is a very very general rule of thumb as this order is concerned. We tried to put it in the best order that we could, but as you know, when things don't work, the level of troubleshooting kind of goes out the window, and just knowing somewhat of a methodical way of going through, or a basic set of things that you need to check, is very, very important. Kind of think of it as a big puzzle, which is what I do. What are you trying to achieve? What are you doing? What have you done? And what do you need to do? So really keeping that kind of mentality through this whole thing is going to be super important. So I would say not always, but a really easy, so we want to try to take these as sort of the low-hanging fruit when you're doing these troubleshooting steps. Really checking the project and preference set data, making sure that's correct. That's probably the most common issue when you're you know, working in a plan and something misfires, or it doesn't look right, or you know, your actual lines are wrong, or your counts are improper. Just making sure that you have that proper project, having that proper preference set up, and frankly making sure that you do use those projects and preference sets correctly. So you know, if you're not familiar with that process, we have that documented, making sure that you have one project per drawing or per design, making sure that you're not using that project over and over and over on different sets of designs, because once you start doing that, that is where things start going awry. That's where your you know, error accessing equipment data comes into play, because maybe you deleted ahead. So just making sure that you have that mentality set up proper will definitely alleviate some of that stuff. So after that, you've made sure that's kind of set up proper. Trying it in a blank drawing. It's such a simple yet overlooked thing. Is if you're in a project and things aren't working right, go ahead and open up a blank drawing. Open it up, assign the same project even, but try what you were doing in that design and seeing if you can replicate it. It might sound a little bit too simple, but if you can identify that it's working proper in a blank drawing, you can isolate it to that drawing specific. Or knowing that if you can replicate it in that blank drawing, it is going to be somewhat of a, maybe you can look into it as a global issue and see what it is that's going on there. So Del Red Japs, audit, purge, cleaning the methods there, that simply is making sure that you have a clean drawing and understanding basic CAD functionalities. So understanding that, you know, a block gets defined in a drawing, and you try to put in a different version of that block, and it's not, you know, heeding those changes. Stuff like purging the old file out. It's that simple, but sometimes is overlooked because you know, AutoCAD has a specific way of functioning. So understanding those basic cleaning methods and CAD functionality is definitely going to help pinpoint where those problems are. The next one that sometimes is overlooked because not a lot of people know how the inner workings of land effects works, tying data to each other, is how you actually add the equipment. We do have an import feature to pull from other projects, but the preferred way that we suggest adding equipment to your project is simply by clicking the new button. That allows you to pick the most up-to-date version, things that we might be changing. We're definitely adding, discontinuing nozzles, updating performance data, and importing from old projects is just going to compound your issue. So making sure that you are aware of what you're adding will definitely help in kind of taking away some of those different options there. So again, even copying one block to another, you know, the data is, you know, needed to make that block function. And if you're just copying a block to copy it, and you're not bringing over its data as well, there could be potential problems there. So how did you actually put that equipment into the project will definitely help in pinpointing where that problem might have occurred. And then down there, 5, 6, 7, 8, using the basic tools, we're going to go through several different combinations of those, but using those highlight tools and the verification tools and even the sizing tools to see how things are functioning in the system is definitely going to be a big key there. So from that, we are going to flip right over into some examples, and I did want to start out with one that may be very common to some of you. This might look very familiar, but just as a warning and a very word to the wise type of a thing. This is what I'm going to show you is sort of the end result or potential issues as you start not heeding some of these warning signs. So going into drawing corruption or just the cleanup in general, you may have seen this dialog box. This dialog box is only going to come up once you've assigned a project to it and saved the file. Upon opening it again, you will potentially see this, if you have problems in your drawing. And we make it very, very easy to click the yes button to see more information on those infected files. And doing so is going to lead you through what that issue is, what the cause is, and what that solution is. Very, very simple. And we definitely recommend following these rules, because if you were to go into this Drawing Corruption Explained, and we have a fun little chart here, and it kind of gives you a little graphic of what can happen. And as you start to heed these warning signs, you're going to start to see some of the issues that start arising in those drawings. And not only reducing the speed of things, but losing your entire drawing. Now, this drawing is not ruined. I could open it, but the problem is when I go to look at any of my data here, I click on him and he just sort of is acting like a standard block, a generic block. It's telling you that you need to save that block because it doesn't know to look for anything there. And if I were to even go ahead and open up this and try to place one of my pieces of equipment, I can go ahead and place him in here. And it even prevents me from adding it, which is really frustrating and quite concerning, telling me that there's an error adding that extended data to that piece of equipment, to that entity. And it has detected that stuff, so it's still prompting us to see what's going on. By bypassing that and hitting no, you're just ignoring those. So while it may let you place things still when you hit no, this can be the end result. View data on anything. I cannot click on one thing without it saying that it's not a land effects item, which is super frustrating because I did this whole entire plan. So having to redo this is not my idea of fun. And we want to make sure that we're trying to prevent that. And that's why we prompt you with those messages. As soon as it starts getting filled with those reg apps, so that is what we want to try to alleviate here is something like this. Now, I'm going to show you a command here, and we're going to actually use this command quite a few times through this webinar. But if you type LOL, enter, and EE, and hit enter, you're going to be prompted to select an object. And the first steps in really troubleshooting something like this, where you get that kind of message or that error accessing equipment data, being able to click on a head and hit F2 to pull up the command list. And you're going to notice down here, this very last set of data here, this is the data that's tied to that object. And A good piece of equipment, and we'll show this to you in a later example here, would actually have the land effects as the handle name or as the reg name here. Instead, there's some other reg app that has wiped out the land effects side of things and put itself in place of it. So while we can actually see what kind of head that was, what we added, all that data is still here. He's ruined because he took out the land effects portion of it. So land effects does not know to look for certain things. And this is what we want to try to avoid. And unfortunately, that happened to any piece of equipment that we did. He's just replaced everything there. So very, very, very hard to recover from something like this. There are certain things that if you were still able to place some of these guys into the drawing, see, we're not even allowed to, oh, he actually stayed, so let's see if he placed. Yeah, see, he's just getting wiped out as soon as we place him into the drawing. So I actually cleaned up this file, so we're going to close this file down. And I nuked this file, and unfortunately, the file size wasn't terrible on the original one there. But it was that amount of reg apps into that drawing that was corrupting that back-end data. So being able to pull open this drawing, we nuked it here, and it won't, nuking and cleaning will not fix these already ruined objects, right? They're still ruined. However, I can go in here, and we'll just try to place that gate valve again next to an area here. We'll just place it right here. So he placed just fine. And if I view his data, he's good now. And if I were to do an LOL, enter EE on him, hit F2, you're going to see I got the proper guy right here, land effects. He knows what to look for, and he's good. Now, I could do an LOL EE on that valve right there, for example, and you can see, oops, he's a drip control valve. He's that XCZ 100, but he was ruined. He's got that app 0 there. So what we could do technically is grab that same guy. We can even place him into the drawing, and he's a good one. He's good. He'll pull up his data just proper, but he won't. What I could do in certain instances to help fix this, and again, potentially in heads and pipe, this will not work, but being able to use match properties, clicking on my good one, clicking on the bad one, it found 12 instances of that block. And if I replace them and look at the view data, it actually has put that data back into that item. So throughout, if I were to highlight that guy, he has now recognized all of those valves through the drawing. So a really helpful way to start fixing a drawing that has been corrupted is being able to use our match properties tool on something like that. So I'm going to leave this one as is, unless, Jared, there's any questions regarding this.
We did get a really good relevant question here from Mark. He was just mentioning that, well, he does try to clean this by nuking a file, and he says sometimes it gets stuck and it never finishes. So yeah, you know, welcome to the wonderful world of drawing cleanup. You know, the thing you can immediately do is, you know, you can try some manual cleanup steps. But there's a whole breadth of drawing cleanup. We have a lot of documentation on it. One thing to keep in mind is as a possibility, you know, because it's all coming from the XREF, mind you, right? This is all coming from these horribly messy files you're getting probably from the civil engineer. You know, really extreme thing you can do, even more extreme than nuke, is down save that file to even a DXF file. You know, there are certainly things that you can do to really dramatically clean that XREF before you bring it in. You have to clean the XREF before you bring it in. You know, but if you're trying to clean your irrigation file after it's already messed up and you're resorting to nuking it, yeah, you might need to be doing something pretty extreme, maybe selecting everything and using the copy clip command and just copy and paste your irrigation plan into a known clean DWG. Lots of things. I don't know if you have a couple thoughts on that as well, Jake.
Yeah, no, I think those are all good. And, you know, on those manual cleanup steps, Amanda has put together a very nice tool. If you're using our AutoCAD cleaned up ribbon, this clean export tool really helps a lot of that, because it does simulate a lot of those manual cleanup steps into one click, which is really nice. But yeah, there's just so many different ways to help do that. I know detaching XREFs and reattaching them can become somewhat of a hassle, especially with multiple changes going on and multiple XREFs and multiple projects. However, even integrating our FXREF tool into the process, I mean, that tool alone on loading XREFs back in is awesome. I love that tool, and being able to just go ahead and detach things and then not worry about UCSs that you're set in and stuff like that. It does speed up the process, but I think you hit it all. I will be hitting, you know, using that match properties tool again a bunch of times, so don't worry about that. And then obviously once you do actually or you're able to convert those things over, those valves or whatever it is, you are going to have to continue to finish through the design. And what I mean by that is, you know, use your verify tools, make sure it's connected properly, size everything again, making sure you have the proper flows. All of that kind of stuff is going to happen again. You're going to have to just do it again. It's not going to pick up where it left off. But you are going to have to continue with that design through sizing and stuff like that. So moving on just a little bit, and just as a FYI, I'm going to try not to jump around, but there are going to be several little examples. So hopefully we hit this a bunch of different times here. So you know, if you need to fall back and watch it again once this recording's up, that'll be your best bet, but I'll try to hit it a couple times so you can see different examples there. So the error accessing equipment data error message there. Now, there's a couple different instances. The one that we went over was a little different because that was completely drawing corruption. But when something happens to, you know, maybe your schedule's off, you're not seeing certain things into the schedule and it's not reading them, and you go into your view data and you actually click on ahead to see what it is, and you get this message. This message is somewhat common, especially if you've accidentally deleted that equipment from your irrigation manager, or you've altered it in some way that it doesn't know what it's looking for. I think the overall rule of thumb, especially on something like this, even before you start placing stuff, we suggest that you run a schedule. And that schedule, so once you add your equipment to your project and you do entire palette, and you just do it to the drawing so that you have it, and that should be somewhat of a reference file for you. Just in case something does happen, you can look in that list, see what you added, and then add it back exactly how it was. So if you were to do that and it actually go through, it's going to be a long list probably, because it is doing everything. And I've got yellow set for fancy reasons, so I'm going to use my layer colors. I'm going to edit yellow and put it to red. All right, now we can see it. So being able to at least see one of each of these, so we have the symbols, we have what we've added it as, all the way down through. This is a great backup reference for that project, for anything that might be missing. But again, I'm going to do my LOL EE, and I'm going to select one of these objects. I'm going to hit F2. You're going to see he's a land effects, a head, a shrub rotary, and he's using that MP2000. Okay, so as long as I have some of this basic information, all I need to do is go into my irrigation manager. I need to look in my shrub rotary and identify if I actually even have that piece of equipment in there, which I don't. So why don't we just add it new, and just go ahead and add that thing back. So that's what I was using. I think it said even the 06 is what I was using there. Add it to the project, hit OK. And the nice thing about this is I don't have to redraw everything. I don't have, my heads aren't ruined. All I need to do is make sure that it comes in like this. I hit view data and it will link itself back up there. And that's the really cool thing about this. So the only thing that you might see different is maybe you placed it as shrub type 2 and you have a circle here instead of the triangle or something like that. Now, those get into, again, a little bit trickier. And as you know, we can add multiple types of that same equipment. And as you start doing that, the thing to keep in mind or keep an eye out for is the actual line item here is going to be a little different in the fact that it's going to have a little parenthesis 2 next to it. And that's one thing that you do need to be cognizant of as you, place these into your drawing, that you're pulling the right symbol in or the right type of head that you're going to do. Because I could go ahead and add this Pro Spray 2 just like we have placed here. But he's a triangle instead of a circle. So understanding that this could be, again, if I even did X list, click on this head, you can see he's LAFX SR2 versus this guy who's SR2000. Now, I am kind of combining a few things here, so I apologize. But if you've noticed, this doesn't have the LAFX, which means my heads here are old because we have updated all of our stuff to have an LAFX prefix. And what's neat about that is, or maybe troublesome, is I'm actually going to place this SR2000 as the type 1. And he looks exactly like this guy, except for with a mask and even updated colors here. So how do I get this guy and all of my existing stuff to look like this guy? And this is a very, very, very tricky one. If you're not aware that my X list, simply a command to look at nested items, he is LAFX SR2000. So my problem is I've got a defined block in this drawing as the old block and the new block. And we've gone through this before in my last presentation where you can do redefine block and update any nested items. So items like this, if I were to block edit him and run the redefine block and pick him, see, he's an old block as well. I'm missing this guy. I'm missing that file, and we don't make that file anymore. So the only way to actually fix these guys, even these guys here, is to do a replace. And by doing a replace and just simply clicking on him, clicking replace, going to Hunter, picking again the same one that we added before, and he was that 2000 guy. They're going to update, they're going to redefine, because we can't redefine something that was missing, but it's going to update and swap that block out for the most up-to-date one. So with a click of a button with that replace, it's going to keep all of my nozzles how they were, but it's going to give me now that newest version. So if I did xlist and check it out, I can see that I've got that SR2000 with the LAFX prefix on it. Okay. Questions for any of that before I move on?
No questions so far, so keep on going.
Cool. All right. So, you know, we've gone through sort of how to correct that symbol mismatch type of a thing. Should be pretty self-explanatory. Again, how did you add it? Keeping in mind that there are multiple different versions, so understanding that that LOL EE is going to be very important as I look at those two items. You can see that both are shrub rotaries, but one's got an S and one's got an S2. So understanding that I've got the shrub type 2 and the shrub type in there is going to help identify how you need to add that back to the system. So we'll leave that kind of as it is. Now, that goes, just to do it one more time, that goes for any type of object that you get that, that message for. So being able to do that EE on any type of object should give you the right information there to be able to understand that that's a quick coupler valve. And it's this rain QC, and this is the one that we should add back to the system. Once we do that, he's going to be totally fine. So just keep that in mind as you use that tool, a very, very easy and quick way to be able to do that. So close this guy out, and we'll start up a new one here. So now we're going to go into, this one's a fun one. I like this one a lot. And we're going to do a little bit of metric on this side here. So this plan has a couple different things that we should keep in mind. Now, when we start getting deeper into finalizing our design and we get into the scheduling and we do our water schedules or our run times and things just don't look right, there's a few things that we can kind of look at. So I'm just going to run real quick a valve schedule. And what's nice about the valve schedule is I can choose what I have on here. So I'm just going to do just a couple of those options there. And I'm just going to drop this here. And you're going to notice that I've got some drip line and I got some bubblers. And I've got my liters per minute here. As I come down here, everything's looking pretty good. And I look at my precip rate and I see this guy. And he is super, super big. And you can find it this way, or when you're doing your runtime or your watering schedule and you see that it only needs to water for 1 minute for the week because it gets all of its water. Something like that really stands out to you. How do you actually start figuring out where to look for stuff like this? So the biggest thing here for the precip rate is the coverage arcs. And we have some great documentation that covers these exact steps, but being able to explain it live is going to be pretty nice. So understanding that you could go into that specific valve and look at that valve analysis here, looking at if everything's looking pretty good here, and then seeing that the precip rate is just crazy. Now, the precip rate is based off of the coverage arc. So that little dotted circle that you see when you're doing your radius, coverage radius there, is, so if we were to highlight this just to see where this guy is at, I've got these bubblers on this valve. So I need to look at the bubbler coverage arc. And what's nice is LandFX does turn on and off that as you pipe and place heads and stuff so that you can see it and then have it hidden. But I'm going to grab this guy here. And I'm just going to place him. And I don't see my normal coverage arc. And what I do see is one right there. He's itty, itty, bitty. And so being able to go into that block, we'll do a block edit. Because again, that coverage arc, the precip is based off of that square footage and volume of water. So being able to open up this coverage arc or this block, see here's our block for our head, and then that is our block for our coverage arc. So very, very easy way to get this back up and running. Again, because this bubbler is being used in multiple places, it's the same block. Being able to go into properties and view its scale. That scale is just super off for what it needs to be. So again, scale it by a reference of a length, or I'm just going to scale him up to 1200 here. And you're going to see that now he's back up to this realm here. And if we were to do a distance on this guy, just like that, he's closer to about 4 feet, which is probably right. So we can start to play around with this. Now, the example I'm showing you here can be applied to your rotors or your sprays if you need to adjust that, or you can just simply adjust it in your schedule in Excel. You know, the formulas and stuff are over there, so tweaking those there in your watering schedules and stuff can be done there. But especially for bubblers, you know, getting a right or closer precip rate for what that coverage is, we want to make sure that we have somewhat of a viable thing there. So closing that, saving the changes, you're going to see now all of my bubblers now have a proper radius there. So we're going to, again, any changes that I make, and this again goes to that troubleshooting step, is you can't just run another schedule and expect it to change. You need to allow that particular valve time to get that proper data. So he's going to go through, he's going to size, size this valve, and we're going to run another schedule now. And you're going to notice that he is much lower than he was before. Now that still is really high for even comparing it to the next bubbler zone here that seems correct. So looks like there's something else that's missing here. So I'm going to look back here, and what you're going to notice is, and this again, if you don't know what you're looking for, it's going to be hard, but having this type of knowledge now, you're going to see that the system creates a region, and it creates a region around that total coverage area so that it can apply that proper precip for that for within that area. And you're going to notice that even though I've got these heads on the zone, they don't have that region. And if I look in properties, you're going to see that I do have a true area for the region I selected. So that's actually the good spot. So there's actually something wrong with the areas here. So how do we find that? You know, we're going to have to do a lot more troubleshooting to be able to see why there's not a region here. I simply selected the block. I did a select similar so that I could see the properties of that specific block, and found some pretty crazy stuff. So first of all, rotation should never be different in blocks like this. And so the fact that we have a rotation on these blocks may be, a different, something wrong here. So we can simply correct that really quick by just putting 0 rotation. And you'll notice that, or if you did notice before, we'll undo that just so you can see, there was a rotation to these blocks, which means they either mirrored them or they did something to be able to have it create that effect. So being able to do select similar, go in there, set that rotation back. So I would do this one step at a time. Okay, so we fixed something. Now let's try sizing. We'll just delete this region area. And let's try sizing that pipe one more time. And nope, still getting that region. So there's still something that's holding up that item. So let's do one more select similar and see our scale is different, which is super weird. Why is there a different scale in the X? Everything should be scaled um, all the same there. So one thing to, again, back out here and check or try is checking your units, checking your precision. Let's go ahead and let's set this full boat precision and just say okay. And I'm going to select similar there. And now I've got, I've still got that varied here. Now, we do need to figure out which one is different, right? So I'm just gonna pop this out. Look at that, I got a position of 0, 0, 0, 0, 0, 0, 2. That has a Z elevation. Didn't find that before with the precision set so tight. So being able to understand that if you pull that out, let's now select similar to all of our items. And I did, just so you know, I do have select similar as a shortcut key. I edit alias and I made it SS. You can right click and hit select similar if you would like, but I use it so much that made it my own little key. So position Z, we're going to set him to 0 and we're going to set him to 1. Let's match him up. We're going to delete this one more time. And let's try sizing the pipe. Look at that. We got 0 leftover radius or regions there, which means that everything went through proper. It didn't leave it hanging there. So we're going to run this valve schedule one more time. And we're going to compare all 3 of these guys. Look at that. He even got down further here. So now this is legitimately what these coverages are for these bubblers for that zone, aside from this guy here. So a little bit of troubleshooting there. Again, not knowing what you're not knowing could be a little bit difficult, but now understanding what it's looking for, how it's working, should help you a little bit. Are there any questions for any of that, Jer?
There's not, but there should be, because I love that. I love when we were going through the
Holy cow.
That was so funny.
So, and I guess I could say, you know, something to look for when you're finding those or reasons behind that, because again, the question is going to be why? Why did that happen? You know, Land Effects is going to be placing things, especially even when you're doing this on 0 elevation, but having a UCS that maybe you set up and clicked to a point that had that slight of an elevation or that slight of a rotation definitely could play into those things. So again, knowing those things, we definitely can start to account for those, but just being as careful as you can as you start to set up drawings is going to help all of that there. So if there's no questions on that one, we're going to move through because we got one last very cool set of examples. This is I think my favorite one. All right, let's just open them up here. All right. And I think this one's even going to be more common than most of these items. So let's see here. One big thing that we stress, and this is to, as you're drawing, as you're using some of these tools, is the proper workflow. For example, being able to use AutoCAD commands in conjunction with Land Effects items, you got to be careful a little bit. And the reason being is because depending on how you use those tools, like our copy features and different things, if you've done them somewhat out of sequence, you are pulling improper data. And what I mean by that is this here. So I've got a drawing, and I know there's no loops in this mainline system. And I know that because I drew it, and he's simply going from my point of connection up. He's stopping here. He's coming back around. He's going over to this area and coming over to this area. So there's 0 loops into this system. I know that. But what's nice is the in the command line, and we'll just expand this just a little bit. In the command line, if I size my main line, and I can, again, do multiple valves, single valve, use my spots. While it's saying looped, this is not assuming that you do have a loop. It's just going to be, if you do have a loop, that's what it's going to be sizing approximately, and same with standard. But if I go ahead and I just hit OK, you're going to see, and I do have some shut-off valves that I haven't connected, which is fine. You're going to see down here in the command line, as it goes through these paths, it's going to tell you if it's a looped path or not. And I got 172 paths, and all of them are loops. And that doesn't seem right. Definitely is something's going on there. So how to actually identify and where those problems are. This one was a little bit tricky, but again, I like puzzles. So if you use your view data tool and you click here, the system is going to be telling you how he's going to be splitting his flow, especially if it's a loop system. So as you go through, it is accounting for 56 flow. Again, you can look at your valve totals to see where maybe that flow is accounting for, and it looks like this guy right here is what's harnessing that overall flow here. And the reason this came up is because I've got a 2.5-inch size after my valve, but I only have a 2-inch and an 1.5 inches before. So why in the world would it be doing that? Again, it's because it's a loop system. I've got 32 coming this way, and I've got 23 coming this way. So this essentially is where it's thinking there's a loop somewhere in there. So why in the world would it be doing that? Again, just using these tools that we have. We already used highlight, and it just highlights there. So nothing's highlighting out of the normal. But what if we use our move piped equipment button? And I'm going to just move this valve, let's say. He looks like he's moving just fine. He's not hooked to any other pipes. So let's go to our next fitting, our shutoff valve. He looks fine. Well, why don't we try this little piece of equipment? Whoa, look at that. So why in the world would he be hooked to every other quick coupler there up until that point? So that starts sort of pinpointing where this is happening. I'm going to place him back down here, and I'm going to pick up this guy. And look at, he's got a different set. He's not hooked to the guy down there anymore. He's hooked to a different set. And I'm going to try one more time. I'm going to keep following it back. I'm going to place him on this. Oh, he's actually hooked normal. So here's what we kind of determined is he's normal. He's not, but he's stemming from here. And this guy down here is totally wrong, stemming from both of them, which means that we've placed this guy, we've piped to this point or even past and copied this piece of equipment after it was piped. And if I do an LOL EE on this piece of equipment and on this piece of equipment, and I look at them side by side, they're going to look the same, which is fine. They can be the same deal. But as I get to this guy, come over here, and Jared, correct me if I'm wrong, it's this 105? Is that right?
Correct. Yeah, the 105s are the pointers to pipe.
Okay.
Mhm.
So this 105, you can see that I got the exact same pointer going on here, which means this is where it's stemming from. And even if I did an LOL EE on this guy and looked at him, you're going to see he's got the same pointer. Okay. So this was improperly connected. And the only way to fix that, again, is to delete this guy. I find it easier just to delete the pipe on both sides of him, even deleting just this set of pipe in general, just to make sure you're clean. But use the tools that we give you to do stuff like this. We have a match head tool. And if I match head to this guy, it will pick him up. And I can put him right there. We'll put him right there. And if I do, we'll just do it for this guy here. We'll do an LOL EE on this one, and we'll do it on this one. And we'll look at this. You're going to notice that I don't have that piece of pipe tied to him anymore. So why don't we go ahead and pipe to him real quick. And we'll pipe here. And we'll pipe here. All right. So if we were to then use our move piped equipment tool, you're going to see that he's got his own. He's got his own. And obviously he was good from the beginning. But now let's try sizing this thing. Let's size the main line. We'll use our spots. We'll say okay, and watch the command line. I still got a loop, but I only have 72 instead. So where is that loop still hanging up? Again, it could be part of those part of these sections here. So we just have to figure out where he actually got tied. But again, going from 170 down to 72, we can really start pinpointing, you know, where exactly those objects started stemming from. So again, that LOL EE tool is very, very handy in that retrospect. So any questions so far on that one, Jer? Anything you want me to clarify?
No, I think that was good. And, you know, we only got maybe 7-10 minutes left. So is that enough for the last little thing you wanted to show?
Yeah, I think it is. Let me just make sure we're good here. So what we're going to do real quick then as sort of the last thing is really manipulating the size of your pipes. Now, again, depending on if you're using a existing, maybe you're tying into an existing part of a main line and you need to make it act a certain way. You know, there's definitely things to, we'll call it trick, but let the system size it differently than what it needs to account for the design that it sees. And the way to do that is we're going to add a cap. So we're going to go to new, auxiliary equipment. We're going to add this cap. And we're just going to bring this pipe cap in for future use. So here he is. I'm going to place him into the end of this system. Now, this flow and pressure can be changed at any time, so we'll just stick with 15 GPM and operating at 45. Okay, so I just put in this little cap right here at the end. Now, you've noticed that I've got a 3/4 inch line coming through here. I've got 1.5 inches up to this point. But I really want this whole line to be a 2-inch line. You know, I want something that is going to give me enough down to this point. Now, whether or not the system's going to allow it based on what the availability is on that point of connection, that's going to be the difference. But what I can do is I can pipe to that cap, and I'm going to size my main line. And we'll go ahead and say okay. Let it through. So again, we had 1.5 inches here, and we had 3/4 here. Just looking through that path too. Say okay. So he stayed just as is. So why don't we go ahead and increase that flow to, let's say, 40. And so this is going to be somewhat of a little bit of a playing game to give it, you know, what it needs to be able to size, or what it needs to be able to give to that area. So we'll go ahead and up him to there, let him run through one more time. Let's see if the system's going to allow that. There we go. Let's look in here. Oh, look at that. Switched over to 2. Let's go check out here. So he's still 3/4 there. Let's go ahead and see if that, oh, see, that's not even a label for that. That's a lateral line. An old lateral line one. I haven't used my verify tools. Shame on me. Again, using verify laterals, verify main on something like this is going to be important. Didn't even show that, so I apologize. But let's even verify those tools to make sure that we don't have anything out of date. Now you'll see that I got a bunch of hatches here without plants in them. Those are my drip area for emitters. So it is going to prompt me that I do have some zero flow areas. And again, zero flows are definitely an issue in a lot of different ways. So again, we do have that all documented. So, but everything else looks good. Say okay. But you'll notice that it did then size my line appropriately. The very last thing that I wanted to show, just real quick, is using flow zones. And again, if you need to size something differently in the middle of a drawing, you know, flow zones are mainly, you know, geared towards golf course irrigation systems where you've got specific flows that you need to restrict down to, but running multiple things at a time. Flow zones do not give you flow. It does limit them to that set flow. But being able to set a new flow zone and seeing that if I want to, you know, maybe limit this piece of pipe down to 1.5 inches, or see what it is going to be sizing it up to. So it is a 2-inch. We don't want that. Maybe we want 1.5 inches. So doing that, dropping that polyline around that specific set of pipe. And again, as long as it keeps the end, the middle, and the other end within that area, it's going to calculate it. So once I size this guy one more time, we'll use spots. Oops. I want to run multiple valves this time. And we'll use spots. Any last questions, Jared, while we let this cook through?
We had a good question there that I was able to answer, but you're also kind of showing, you know, in terms of sizing the main line, is just the ability to kind of dial in the size desired, you know, combination of using a cap, using flow zones, so that the system is still doing all these calculations.
Right.
I'll let you keep going with the narration here.
Cool. So now what changed with that, and this is interesting, is we did multiple zones at a time, which flowed a little bit bigger. It said it needed to be 4-inch, which means it did bump all of this stuff up to 3 here. But again, it did limit us down to the appropriate size for these areas here. Now, already labeled. Just gonna move around here. So you can see that it did shrink that down and then bumped it back up. So if I were to look at my actual flows through those pipes, you're going to see that I've got 92. Now it's down to 40. Now that split it. Can you explain that one, Jer? It did cut it in half. That's weird that it did not respect the 25. Any thoughts on that?
I didn't, I didn't see which way it's coming from. If the flow is already more than 25 by the time it hits that flow zone, it's not going to be able to do anything there.
Oh, yeah. So that's probably what it did. Smart guy. So, it limited. Yeah, it did. It limited to what it was there at that point. So, which is awesome that it didn't let me not size it appropriately. So,
but you could change it to say 60 GPM, I guess, right? And it should then limit it to that.
Yeah, definitely would. So, anyways, it looks like we're 1 minute over. But if there's any last questions or anything like that, that went by way too fast. And just something to keep in mind is, again, the layers that you have set, the preferences that you're using, making sure that you just take a step back when something doesn't work. Just don't freak out. There's a reason why it didn't. So try to replicate it. Try to understand where things are coming from, and hopefully a few of these little tips and tricks there for that troubleshooting will help in kind of pinpointing that using those tools that we do have available for you. So
exactly, use your power wisely, right?
Yeah.
But yeah, no, definitely. I think I hope you guys saw that. Definitely, when you send these drawings into us, we're for the most part using all of the tools that are already in the software. Granted, there a couple sort of somewhat hidden tricks of LOL, EE, but for the most part, yeah, I pretty much everything that you saw is, looking for things, and that's pretty much what we're going to do. And that's definitely what we ask is maybe before just sending a drawing to us and saying it doesn't size or preset rate is wrong, is, kind of investigate it a little bit for yourself. Just look to see if something seems wrong. See if you can solve the puzzle. Definitely helps us a bit. And it'll definitely help you in the longer run because you won't have to wait for our answer on every time, right? So that's always a good thing. But
even though we're really quick.
Even though we're super quick. But anyway, thank you, everybody, so much. Thank you, Jake, and have a great weekend.
Thank you, everybody.